That's all for common wired communication technologies in the IoT. Next, let's look at wireless communication technologies. As we just mentioned, there have three categories: short-range wireless communications technologies, cellular mobile communication technologies, and LPWA communication technologies. I will introduce wireless communications technologies that fall into these categories and explain their differences. After that, I will make a simple comparative analysis of them. Let's start with short-range wireless communications technologies. The first short-range wireless communications technology we are going to talk about is Bluetooth. This technology is everywhere in our daily lives. It is used by mobile phones, computers, tablets, and other devices. In the IoT, devices like smart watches and smart scales are used Bluetooth. Bluetooth used for transmission ranges from about 10 cm to 10 meters, which is relatively short compared with other wireless communications technologies. It provides a high transmission rate up to 1 megabits per second. The latest Bluetooth 5.0 supports a transmission rate of up to 3 megabits per second and can transmit over about 300 meters. This technology can be divided into Bluetooth basic rate, enhanced data rate, which is BREDR, and Bluetooth low energy, which is BLE. The BREDR type supports only point-to-point communications, whereas BLE supports point-to-point, broadcast, mesh, and other modes of communications. The BLE type is mainly used in IoT scenarios for data transmission among multiple devices. Next, let's talk about Wi-Fi, a technology that we are all familiar with. Wi-Fi is widely used for daily internet access at home or in the office. Wi-Fi usually uses the 2.4 GHz and 4 GHz frequency bands to provide different services for different devices. What are the characteristics of Wi-Fi? Wi-Fi has a longer range than earlier versions of Bluetooth. It also supports one-to-many connections and faster transmission. However, it has poor security and stability. You likely have experience with this in your daily life. For example, video freezing when watching a video, and a long delay when playing games. The delay may be 20 milliseconds to 30 milliseconds, or even 100 milliseconds to 200 milliseconds. Wi-Fi also uses a lot of power. Similar to Bluetooth, there is a next generation Wi-Fi standard, Wi-Fi 6. This version supports a transmission rate of 9.6 gigabits per second, and the latency is kept down to 20 milliseconds. The next two short-range wireless communications technologies are relatively new. You might not be familiar with these two. The first is Zigbee, a technology featuring low power consumption. Let's go back to previous slide. You can see Wi-Fi devices can only be connected to access points or master concentrators. However, Zigbee is different. Zigbee allows for data transmission directly between devices. It means that Zigbee networking is easy. If the AP in a Wi-Fi network is faulty, the entire network breaks down. This won't happen in a Zigbee network, because each device on a Zigbee network functions as a relay. If a device fails, the network adjusts on the fly to find another device that can take its place. The name Zigbee is derived from the waggle dance that honeybees perform through movements such as zigzagging to communicate the location of pollen. In other words, the waggle dance can be thought of as their communications network. This is similar to easy networking of Zigbee. The cost of Zigbee module is as low as $2. The transmission rate is 20 to 250 kilobits per second, which is very low when compared with Wi-Fi. Zigbee is also lacks robust compatibility and is difficult to maintain. The next is Z-Wave. Z-Wave is similar to Zigbee, but Z-Wave is more reliable. In addition, Z-Wave is not open source. Z-Wave chips can be obtained only from Sigma Designs. In the initial design, the Z-Wave technology was intended for wireless control of smart home appliances. Data was transmitted in a small data format, and the transmission rate of 40 kilobits per second was adequate. When the technology was first utilized, a rate of 9.6 kilobits per second was used. Compared with other short-range wireless technologies, Z-Wave uses a low transmission frequency, can transmit over longer distance, and is priced competitively. Now, let's compare the four short-range wireless communications technologies. Bluetooth and Wi-Fi have higher transmission rate. Earlier versions of Bluetooth only support one-to-one connections, whereas Wi-Fi supports one-to-many. Bluetooth is mainly used on devices such as mouth devices, headsets, and mobile phones, whereas Wi-Fi is mainly used for high-speed internet access at home or in other indoor environments. Zigbee and Z-Wave feature low transmission rate and multiple connections. They are often used in the IoT field, such as home automation, smart home, and smart building. They are unlikely to be used outside of IoT because of their low transmission rate. Now that we are familiar with short-range wireless communication technologies, let's take a look at the cellular communication technologies. First, 2G. 2G has been around for a long time. The emergence of 2G marks the origin of digital communications. The full name of 2G is Global System for Mobile Communications, or GSM. On a 2G network, we can make calls and send SMS messages. Later, GPRS emerged. It is also known as 2.5G. It has a higher transmission rate than GSM, and it can be regarded as an upgrade to GSM. A 3G network provides a higher data transmission rate, which can reach hundreds of kilobits per second. Over a 3G network, we can make video calls and watch TV programs using mobile phones. In China, 3 major operators use different standards for 3G networks separately: CDMA 2000, WCDMA, and TD-SCDMA. HSPA Plus, the latest WCDMA technology from China Unicom, supports a maximum transmission rate of 42 megabits per second. But so far, HSPA Plus is still used in most video data transmission fields. If we want to transmit HD video, we need 4G. Although 5G is not popular, most of our mobile phones still use 4G. Over a 4G network, we can use our phones to stream video and listen to music. For most of us, the most obvious difference between 3G to 4G is the amount of data we get with our phone plans. With 3G, our data plans were measured in megabytes, but with 4G, we have data plans measured in gigabytes. In the LTE network, another thing I want to share with you is LTE CAT. LTE CAT is a set to 4G standards. CAT stands for category. Each different category refers to a different transmission rate level supported by the UE when accessing a 4G network. Each level specifies the maximum transmission rate that the device can reach. In the earlier days of 4G, our UEs were Category 4, but now most of 4G devices are Category 6. Module chips for devices at different levels are different prices. In the IoT field, Category 1 UEs are widely used because some devices demand high network rates, although most of devices use LPWA. UE Category 4 or later provides a higher rate, but its modules are too expensive for IoT devices. It is more cost-effective to use UE Category 1. Now, let's take a look at the hottest technology, 5G. The theoretical peak transmission rate can reach 10 gigabits per second. 3 5G application scenarios are defined. eMBB, which is defined by a rate of up to 10 gigabits per second. MMTC, which refers to support for up to 1 million connections per square kilometer. URLLC, for when latency has to be kept down to 1 millisecond. In this course, you only need to understand these 3 scenarios, and I will explain other aspects of 5G in subsequent courses. Let's compare the cellular networks mentioned above. Technology continues to evolve, and we are evolving from 2G networks to 5G network. As you can see, the frequency band we use is getting higher. We have moved from the 900 MHz to using millimeter wave bandwidth, and the corresponding transmission rate is increasing. The bottom column lists typical applications for these technologies. We should choose the most appropriate network, not necessarily the best one. For example, there is no need to use more advanced networks for POS machine or vending machines, since the technologies in use can fully support their functions. 5G is relatively expensive, so it is not necessarily the best match for all the solutions. Now that we have familiarized ourselves with the cellular wireless networks, let's take a look at LPWA communications technologies. LPWA is short for Low Power, Wide Area. As we mentioned before, LPWA provides large coverage with extremely low power, which makes it great for IoT development in the public utility sector. Let's start with Sigfox. Sigfox is the name of an IoT technology startup company in France, and is also the name of the LPWA communication technology developed by the company. Sigfox is designed for low-throughput projects. It can maintain stable data connections with less transmission power. Sigfox exists to store the massive amount of data generated by IoT devices, but it is not sufficiently trusted for data storage and information security. All this makes Sigfox not as popular as LoRa. LoRa is short for long range. Different from Sigfox, LoRa is maintained and managed by the LoRa Islands. The LoRa technology was developed by Semtech with joint efforts of the LoRa Alliance. Semtech developed LoRaWAN, which is applied to the LPWA field. LoRaWAN is an ultra-long-range wireless transmission solution based on spread spectrum technology. LoRaWAN mainly runs on unlicensed frequency bands. Now, let's move on to NB-IoT, which we will go into more detail on in the next course. NB-IoT is short for Narrowband Cellular Internet of Things. NB-IoT was first proposed by Huawei and Vodafone. Later, companies such as Ericsson and Qualcomm joined its development. NB-IoT takes advantages of existing cellular networks. It only needs about 180 kHz of bandwidth and can be directly deployed in the existing cellular networks, greatly reducing the cost for operators. The last LPWA technology to be mentioned is eMTC, which was proposed by Ericsson based on the 4G networks. It is mainly used in IoT scenarios that require deep coverage and a considerable number of connections. Compared with NB-IoT, eMTC has a higher rate but provides less coverage and requires more power. It supports voice communications, making it popular in scenarios where voice communications are required. Let's look at the comparison of LPWA technologies. Sigfox and LoRa run on the sub-GHz unlicensed frequency band. Sub-GHz means that the frequency is below 1 GHz, which mainly refers to the frequency band from 27 MHz to 960 MHz. Sub-GHz is an ideal choice for long-range, low-power consumption communications. Why? Given the same power, higher frequencies are less able to pass through physical obstacles. Devices in LPWA scenarios, such as electrical meters or water meters, are often placed deep underground, so penetration is important. They need to run on low-frequency bands. NB-IoT mainly runs on sub-G licensed frequency bands, but some NB-IoT networks run on frequency bands higher than 1 GHz. We will focus on the specific reasons in the next course. So far, we talked about 3 types of wireless communications technologies: short-range wireless communications technologies, cellular communications technologies, and LPWA communication technologies. All these technologies can be applied to the IoT. How do we select a right technology for a given application? This figure can help. From this figure, we can see which technology works best for different scenarios. The 2 axes in the figure are the transmission rate and transmission distance, which correspond to major requirements for different IoT scenarios. There are 3 types of data rates: high, medium, and low. For example, Internet of Vehicle, which is IOV, requires a high data rate. Smart logistics and vehicle management require a medium data rate. Metering requires very low data transmission. We can further divide these scenarios based on the transmission distance that must be supported to get 6 types of networks. As we mentioned before, we must select the most appropriate technology for our specific application. In addition to the transmission distance and transmission rate, we need to consider costs too. We need to maximize our return on investment. Now, to briefly summarize, in this course, we learned about common IoT communications technologies. There are wired and wireless communication technologies. Wireless communication technologies can be further divided into short-range wireless communication technologies, cellular mobile communication technologies, and LPWA communications technologies. We also learned the characteristics and application scenarios of these communications technologies, and how to select them in different solutions. That's all for this course. In the next section, I will introduce the key technologies and solutions of NB-IoT, which we mentioned many times before. What advantages does NB-IoT have, and why does NB-IoT have them? What are NB-IoT solutions available? Thanks for your watching. See you next time.